Good morning, students. This side Open Rai, and I will be teaching you about Python from the very basic to the advanced level, as much we need to learn for landing a good job or learning every opportunities. So today's lecture in first we will start with the programming and translators. We will see what they actually are before start learning Python. First of all, we need to know what exactly is programming. It is giving a clear instruction that programming is the process of writing a set of instructions that tells a computer how to perform a specific task. That means we are giving a set of instructions to the computer to let them know that I want them to do this specific task for me. This will do a bunch of stuffs, and for that we need to give a set of instructions which we call programming. Usually computers follow these instructions. They never guess or assume when we give a set of instruction, and it's the art of problem solving. Real life programming examples. When talking about programming, we have to know about the real life examples, otherwise we can't understand what programming actually is. Like when we cook Maggie, a step by step recipe is an algorithm. A missing single step would make the Maggie very bad in taste or something. It breaks the process. So it's a program and set of algorithm. It's actually the program. Google Maps, millions of instructions, calculate traffic, distance, and ETAs automatically in milliseconds. So this is a programming algorithm which tells us about where the traffic is more, where the traffic is less, and many more. Then comes the ATM machine. From reading our card to dispensing cash, every action is a precise computer program. Like in ATMs, we enter the card, swipe the card, enter the pin, the cash is coming out, or we are giving in the cash. Everything is an algorithm. Everything is a structured program. Now we're talking about program versus programming. When we talk about program and programming, they both sound similar, but they aren't. The main reason is when we talk about the program, it's the finished product. It is a collection of instructions used by user to solve a program. Example, a set of code written to make a YouTube app or a calculator. It is a program. It is a set of instructions. But when we talk about programming, is the process. It represents the process. Is the act of designing, writing, and maintaining the instruction done by the programmers. It is the process, and programming is the art which is being done. For a simple example, we can take making a cake. It is programming, and when the cake is finished, it is the program. Now we will talk about the binary language of CPUs. It is very important when we deal with programming because binary things are everywhere. In coding, what we actually deal is about binary, and I guess everyone knows that computer system understand only binary. So binary digits, bits, we all know. Machine language, it is the accepted machine language. Actually CPUs only understand 0 and 1. A sequence of this is what we need for uh, binary. Machine language is the only language that is directly understood by the CPU. As I already told, it consists entirely of binary digit, and binary digit means a combination of 0 and 1 only. It doesn't understand anything other than 0 and 1. Humans cannot easily write in binary, So we create a higher level language like Python, which we will be learning further. Digital reality. Inside a computer, everything is represented using only 1 and 0. As I already said, this is the foundation of every and all software, from simple calculator uh, program to complex AIs. Everything that happens is purely based upon the binary uh, things that we are learning. Everything the CPU understand is only 0 and 1 and combination made by them. Since humans communicate in natural languages, we need a way to bridge our logic to this binary reality. The CPU understands only binary, and humans communicate in natural language. So to bridge between these two, we create a thing that we call programming. So we'll learning more about that. Bridging the communication gap. Language translators, very important. We all know about language translators. uh, it's a thing that translates our languages, like we use translators for communicating in different languages. It is the same, but here it translates from natural language to binary. A translator is a system software that converts high level language such as Python into machine language binary. The high level language Python is understood by us but not by the machine, whereas the machine language binary is understood by CPU and not by us. So this language translator uh, acts as a bridge between these two, because without them computers would be unable to understand the code we write. So it is a very important thing, and we should be learning more about this. The primary language translators. Assembler. What is an assembler? Assembler is a thing that assembles everything. We usually know this. Assembler converts assembly language into a machine language. The assembly language is a low level language which is converted into machine language which the computer understands. Then the compiler, it translates the entire program at once before execution, which is usually done in C, C++. The entire program is being translated much before the execution happens. Interpreter, this is a different, and this is mainly used in Python. In interpreters, it translates and executes line by line. It translates a line, execute it, then goes to the second line. This is a difference between the compiler and interpreter. Compiler first of all translates full program, then executes, whereas interpreter translates a line and then executes the line and then goes to the next line. Python is primarily used the interpreter. This is the difference I was talking about, compiler versus interpreter. Compiler, when talking about in sense of conversion, compiler whole program at once, compiles the whole program at once, whereas interpreter converts line by line. In case of execution, compiler compiles faster, whereas interpreter con um, executes slower, because it has to do line by line, so it's much slower. In case of errors, reports all the errors at the end in case of compiler, whereas in interpreter stops at the first error. So it makes your code much better when you can't go to the next step without solving the error in the first step. In case of output, compiler generates executable files, whereas interpreter does not, has no executable files. So we can fairly understand this, what's the matter with this and what's happening actually. Now, Finally, to the Python part, how Python executes our code. We write a we will write a program and everything, but how does it gets executed? It is very important to know that. So first step is the Python code, the code we write, which is also known as the source code, which does the work for us. Then is the bytecode, then comes bytecode. This is the second step that happens. It is the intermediate version created by the interpreter. It This is the version that is being converted and created by the interpreter from the source code that we write. Then comes the PVM. This is the third part. PVM stands for Python Virtual Machine. In this part, the Python Virtual Machine does the execution of the intermediate version created by the interpreter, that is the bytecode. It executes it, and the final part is the binary machine language output. That means it is the output given by the machine in machine language, that is binary format. So it gets converted and we get the result. When we talk about programming, we first have to know that it's not only IT sector that uses programming, or not only some limited things that use programming. Programming is everywhere. Everything we use, everything we does has programming, because without programming, without instructions, anything cannot work. So the first is the diverse languages. Python, Java, and C++ power the modern web. These are the main languages that are ruling today. If we have to do something in the field of CS, we have to know this: Python, Java, and mainly C++. Then comes the smart systems. It also uses programming. In this, IoT, Internet of Things, laptops, and smartwatches are controlled by code. Without code, they are nothing. They are a piece of hardware that doesn't work. And the last is the software logic. NASA, Google, and everything uses millions of code, because these big companies, these big softwares need a huge amount of code to run and function. Now there might be questions which be rising. Program is a practical skill. You can become a programmer by writing code. Simple as that. If we practice, if we grind, we all can be good programmers by but writing code is very important. Seeing the code, memorizing it will not work. We have to write it down. So there will be a small wrap up of the lecture 1 that we did here. That is, we understood the logic, respect the binary, and embrace the translator. We talked about three parts. First is the logic, second is the binary, third is the translator. I hope everyone understand it. If there is any doubt, you can write in the comment section. What is Python and your first Python program? We have to know about this. What actually Python is, and what will be our first Python program. So what Python is? Python is simply a high level language that uses interpreter to execute itself, and mainly the general purpose of Python is everywhere. It is not limited to one specific domain. We will be talking about that. First, it is a high level language. That is, syntax is incredibly close to human language. The syntax what we will be writing is very similar to normal English that we speak. It's very basic. Like when we have to print something, we use print syntax. When we will be doing writing the code, we will be understanding it is very simple. Like we have to take an input, we use the input syntax. It comes automatically after some time. So we will be learning about that. First, it is a high level language. Syntax is incredibly close to human language. No complex syntax or direct binary interaction required. There is no direct binary interaction ever required in Python unless and until we are working with binaries. Interpreted, Python is interpret. That means it is being compiled step by step. Code is parsed and run directly line by line without required an explicit manual compilation step. I hope you understand. We already talked about this. General purpose, not limited to one specific domain. Python is used everywhere, not only in one field or one domain, such as powers AI, one domain. Second is web apps. Third is automation. Fourth is data science. Fifth is cloud backends, and everywhere, everywhere. Wherever you are seeing coding, there is a scope for Python. Now let's talk about the origin and philosophy of Python, the history of Python. Guido van Rossum in 1989 created during the winter of 1989, named after the British comedy show Monty Python's Flying Circus, aiming to make code fun and accessible. The Zen of Python: simple is better than complex. This is the Zen of Python, and it actually follows because Python is pretty simple and it works everywhere. Python heavily emphasizes clean formatting, human readability, and writing drastically fewer lines of code. Yes, that is a very good point because in Python we will be writing very little amount of code. Only the amount of code it is we are required to write, because when we will be writing the code we will be seeing it that in languages such as C, C++, and etc., there are things like we have to write 20 lines of code for a simple program, whereas in Python we will be writing only 8 to 10 lines of code and the task will be achieved, because it has very clean formatting, no extra line of codes, and very good human readability, and we write really drastically fewer lines of code. Now there are the key features of Python: highly portable, runs flawlessly on Windows, Macs, and Linux out of the box. Very much portable and pretty much runs everywhere, we can say. Batteries included, massive built-in library support. The best part of Python, a massive built-in library. We just call in the library and uses the library functions there, and 50% of our tasks are done, and we have to don't write any code for that. Single line of code can do a lot of work using the built-in libraries. Obviously there are many built-in libraries such as math, JSON, OS, datetime. This helps in many things. When we will be writing codes, you will say using this math built-in library we can do any complex mathematical calculation, square root, anything, just by one single function. Then comes dynamic typing. It's very important. It's a very important thing that it does. Dynamic typing. Variables instantly scale contextual without explicit data type declarations. It's very useful and very needed. We will be seeing a dynamic typing example also. Here in the example area, I will be marking it. Here we can see an example. Here it tells the age is 19. It is an integer type. What is integer, what is string, what is float, we will be learning more about that. But for the timing, just know integer means the mathematic integer what we talk about, that is in whole numbers. Name equal to Upayan. This is a string. String means a collection of alphabets or a word, collection of words, anything that we write within the double inverted commas. Marks 95.5. Float. Float numbers, floating numbers, we have read about it. Anything in point is known as float. Then comes the trade-offs and limitations. Execution speed. Because it is an integrated language executing statement by statement, it is natively slower than compiled ecosystem like C or C++. C, when it comes to speed, C and C++ are very fast and very good, and obviously they have to be, because in case of Python we interpret line by line. We translate, then interpret, again translate and interpret. So it is a slower process. Whereas in C and C++, they translate the whole program, they execute the whole program. So it is faster. Memory consumption, high flexibility and automatic garbage collection overhead mean higher structural memory footprint, which is better which is better actually as in Python. Mobile constant, rarely utilized for structured mobile clients, where language like Swift and Kotlin excels natively. So Python doesn't work very much in that. Ecosystem comparison, Python versus C, very important. When it comes to syntax style, when it comes to syntax style, in case of Python, it is minimalist, highly conversational, and English-like, as I already said. When we will be doing it, we will be seeing that it's very much like English. Python code is very similar to English language that we write, speak, and talk in. And in case of C, it's strict structural syntax over. We have to learn a lot of syntax in that. It has a bunch of structure that we have to write every time we write even if you write a single line of code, we have to write the structure, which is not in case of Python. In case of execution, Python is interpreted dynamically line by line, whereas C language is compiled fully down to the binary machine code ahead of time, which makes C language faster than Python, obviously. In case of development speed, extremely fast for Python. Rapid system prototyping, it is faster in case of Python. In case of C, it's much slower, requires precise architecture management, because I already said they have a structured structure which we have to use every time. For memory control, automated structural garbage collection is there in Python, which is a very good. And in C language, manual memory life cycle conversion, which is much slower, but it's fine, obviously. Industry applications and corporate adaptations. Python is trusted by global entities like Google, YouTube, Instagram, and NASA. And it's very important. When companies this big are trusting a language, it has to be important. Otherwise, they wouldn't be trusting it. AI and deep learning, foundation learning by OpenAI, ChatGPT, and large-scale LLMs. Data analytics, industrial engine powering global business intelligence framework. web backends, power production stacks across Instagram, Netflix, Spotify via Django and Fast APIs. Don't get confused. Django, Fast APIs, they are the other parts of Python where you'll be learning about more about Python and compiling Python with other things. You'll be learning about this. For the industry application and corporate adaptations of Python. Now we will the wait is over. We will be writing our very first Python code, which is pretty simple and easy to be precise. Let me get it. Yes. So the Hello World convention is the historical universal first step of every developer in software industry. When I first learned coding, this this was pretty much my first code as well. So here we will be talking about writing this code. So there is a step-by-step instruction. Open your workspace directly in VS Code. Yes, VS Code. This is very important thing. VS Code. I hope before starting this lecture, everyone downloads it. There are many. It's very easy. Go to the Google Chrome, write VS Code, and you will get this. And just you have to, I guess, means VS Code is a workplace where everything is there. Everything from if you are writing Python, every built-in library will be there. Python is there. If you are coding in C, C++, Java, any language, everything is supported there. So it's very good for coders. Write a fresh file, create a fresh file called hello.py. .py is the format of saving a Python file. If you don't write .py, it will be not saved as a Python file, but it will be saved as a text file by default. So .py is very important to be written. Write a print command exactly as shown here. Here. Now I will be coming down to here. So has we will this is the file name given here. So we will be printing a simple thing that is hello world, and for the syntax we have to write we are printing, so we will write print. As I said, it is very easy and English alike syntax. So write print in bracket, use in double quotation whenever you are write whenever you are printing anything directly, use double quotation. In double quotation write hello world, and here it goes. It is the output, terminal output. It comes below the code just. So here it comes hello world. So the execution architectural flow, we are very much at the end of our lecture. Here it shows the source code that we write. As I said, it the source code goes to the compiler. The source code goes directly to the compiler. The compiler compiles the line by line and send as a bytecode and send as a bytecode. Let me change the color. Send as a bytecode. Here it is converted as I already said. Then it is set to PVM, the Python virtual machine, where it is compiled, changed, and executed. And then comes the machine view output. So this is pretty much the thing that happens. We already talked about it. Here is the deconstructing the Python print function. We will be doing using the print function more to understand everything that it can do, and it does actually pretty much. So here the flexible output handling. The standard system function to emit text, numerical evaluation, and multiple comma separated variables to runtime terminal. Using this, we can print text strings, numerical evolutions, and multiple comma separated variables to run in the terminal and to get printed. Strings must always be safely bounded within quotation marks. That's what I was saying. If we are printing a string or word or combination of anything, that has to be printed as it is or as written, so wrap it in quotation and it is good to go. Like print welcome to Python, just as we printed uh, hello world. Here print and bracket 100, it prints the digit. Chaining text plus numerical data, here it gets prints as age equal to 19. It gets pretty much like this. Here we use the print function, then in quotation we write the syntax, and the in quotation wrapped we write the string that we have to print, that is age equal to, it will be printing that, and then the digit that has to be written beside the equal to that is being assigned is, we write a comma and give the digit value. It's pretty simple. Yes. So Python is very case sensitive. Activity and tokens. We have to talk about the case sensitivity and tokens of Python, which is very important. Case sensitivity. Python structure evaluates uppercase and lowercase variables as entirely separate operational blocks. That means Python is case sensitive. If we're writing print in capital, in the first character of print as capital P and then small, it raises error because print has to be fully written in lowercase. This is the case sensitivity. Python evaluates the uppercase and lowercase variables differently. Whenever you write capital print or capital print, small rint, then it acts as a variable and not as the print function. Keyword commands are absolute, modifying casing breaks evaluation completely. Here is an example, you can look to it. The age is 19, capital age is 25. These two becomes different variables only because capital A and small a. And when we using print, as I said, it will raise name error. Common syntax pitfalls. These are the problems we face, and we will be facing more when we are beginners. I also did. Syntax error, missing quotes. Python interprets text variables very strictly. Omitting wraps or quotation forces an identifier lookup, such as here. Here we wrote print quite good, then print hello. We have not used quotations. We have not wrapped hello in quotations, which creates the error. We have to give quotations. Here, this is the syntax error, missing quotes. There is a syntax error, unclosed paren. What that means? We haven't closed the parenthesis or the bracket we have used here. Leaving execution parenthesis open causes parser tracking fall downstream. Here we have written print, here the bracket is there, hello is there, everything is fine, but we haven't closed the bracket here. Here is the fault. Here we have to close it and it's good to go. So here our lecture 1 completes the fully part of the beginning of the Python. So I hope everybody enjoyed it. If there is any doubt which I can solve, or you have while you are learning this, feel free to comment it down in the comments. I'll be checking it and obviously give you the answer if I can. Thank you.